We have a number of curious and exciting topics to share with you. Our series highlights an eclectic group of speakers, experiences, and workshops across a broad range of subjects in the areas of culture, design, science, technology, art, fabrication techniques, and lost common knowledge. As attendees of the Hand-Eye Supply Curiosity Club, you are now all members, provided you adhere to our philosophy. Ex curiositas scientia. We pledge to learn without prejudice in pursuit of our mutual goal, perpetual noviceship. We admit that it is impossible to know everything about anything, and thus we remain perpetually curious and perpetually novice. This is our flag and our mascot, Franklin. The lightning bolt represents the receipt of knowledge, the enlightenment of illumination, the resonance of truths understood. It awakens us and excites us and makes us hungry for more. And now, I'm very happy to introduce Stefan and Andrén of Krown Lab. Krown Lab is a Portland, Oregon-based design company creating and manufacturing timeless products for commercial and residential spaces.
Thanks, Will. Nice to be here. Yes, my name is Stefan Andrén. I've been asked to talk a little bit about Krown Lab. But just to give you guys a very quick background on me so you know who I am, because I do have a life before Krown Lab. I was born in Sweden, grew up there, and came to the States originally to El Paso, of all places, on a tennis scholarship. And yes, I was able to come over here. El Paso wasn't everything I had envisioned America to be. So I was able to transfer and get a scholarship in Chicago instead. And I studied architecture first and then industrial design there. Moved to Art Center, did some more study there. That's Pasadena, LA. Then moved back to Chicago for a job, the consulting firm. Then worked to Motorola, moved to Milan, was there for a few years, and then moved to Portland because of Nike, and left Nike 3.5 years ago, and still here in Portland. And so my background is in product design, so I've designed a lot of different products in a lot of different kind of categories and sizes. I'm not going to go into any of this right now, but if my background or my education is industrial design, then you start as a young kind of designer just focusing on products, a lot of sketching and styling to some extent. And then you get some more experience and you kind of products and graphics are very closely linked. A lot of products have graphics, so you kind of get your feet kind of a little bit deep into that. And then as you get more experience designing products, you get more interested in development. At least I did, because I realized for the first couple of years that if I just handed my sketches off or my drawings off to the engineers, when they were done with it, it just didn't look like the way I had envisioned it. So I was really interested in learning about that and design in a way that I could actually get my ideas to kind of go through the gauntlet of development and manufacturing and turn out well in the other end. And then, very many designers kind of bridge the gap between product and user interface. You get experience with that. You do packaging at some point, as I did. Then point of sale is an extension of that, and then web design is another way to kind of communicate your product. And then you kind of maybe zoom out a little bit further and you work on brand, and then line planning as in multiple products, and then product strategy. And then before you know it, you're kind of working, or you have dipped and dabbled a little bit in kind of all aspects of kind of a user experience. And in doing that, at least for me, it's like, I'm like, hey, well, I want to do this for me. I don't want to do this for anybody else, and that was one of the driving forces behind me starting Krown Lab, is the wish to do something where I could make whatever decision that I or us as a group felt was right, as opposed to have a very streamlined decision-making process. like I said, that's one reason why Krown Lab kind of came about. But the real reason actually is kind of a happy accident. So when I first moved here, and it's because of a house, of all things. So when I first moved here, I designed a house, and totally kind of, I did it in Alias, which if any product designers in here, you'll know that that's the worst program in the world to design a house in, but I know it kind of well, and it kind of worked out, I guess. At least there were no surprises, as in I felt that I knew what the way it turned out, I had already kind of seen on the computer. And this is kind of the kitchen, and that's the finished kitchen. But totally kind of low budget, a lot of custom solutions to keep the cost down, using residential windows to look like storefronts, and lots of unusual details perhaps. And one of the many kind of custom design details or products that were created for this house was some sliding door hardware. There was no money to buy the expensive products on the market that are kind of more contemporary looking. They tend to be from Germany, and barn door hardware in a space like this didn't quite feel right either. So I figured, well, how hard can it be? I mean, I'll just design some hardware, and it just needs to go back and forth and not fall off the end. So I did that, and this is the very, very first prototype that's in that house. And the house received some publicity, books, magazines. Dwell was really the magazine that kind of made a difference, because it wasn't featured in Dwell in 2006 or something, and then people just started calling and emailing, find my number somehow. I was still working for Nike, and they're like, we want this hardware, where can we buy it? And there was a misprint in the article where it said that the hardware came from McMaster. So most phone calls started like this: I've been on the phone for an hour with a rep at McMaster, and they swear they don't have this hardware. And the bearing was bought there, and there was a small miscommunication between me and the journalist on that one. But anyways, and people started calling and emailing, and I figured it would kind of go away. So I said, sorry, it's custom, I can't really do anything for you. But it wouldn't stop. So I made a small batch of them. A friend of mine is a welder here in town. So I think, can you make 40 of these? And he's made 40 of them. And I kind of sold them out of my garage if somebody bugged me long enough for them. And a few years passed, and 2008, people were still calling and emailing. And at that time I had left Nike. I had started thinking about, well, what I want to do, and I want the autonomy, and obviously I can't do consumer electronics because I don't have a $250 million laying around to do that on my own. And then this started to kind of solidify. I did more research. I couldn't understand why people were still calling and emailing. They just go buy something else on the market. But there was a big void. And the decision was made to, okay, let's give this a shot. And so that's probably the main reason why Krown Lab exists. So some of the driving force behind Krown Lab is, I've always been very interested in bearings. I think they're beautiful. Never understood why you have to hide them and cover them up with rubber and plastic and other bits. And that was kind of how I approached the original kind of prototype with a large bearing. So one of the early decisions was, we're making the bearing a very key element of all the products that we do for sliding door hardware, which is all we focus on today. So this is the kind of a product lineup. You have Rob Roy, Odin, and Balder. So I'll tell you a little bit behind, the reason behind the names, and a little bit about the products. So Rob Roy is first, and Rob Roy is called Rob Roy because my friend Rob Roy was the one that welded the first ones. So we wanted to call it Rob Roy to kind of pay homage to him. As we were kind of very, very early on, we only sold this product. He was still kind of helping us out, cutting and welding it. And then it got too big for him to handle, so we went a different route. But Rob Roy is not the Scottish freedom fighter, it's the welder from Portland. And Rob Roy, was designed to kind of maintain that original design's very kind of raw and industrial look, with very sharp edges and very, very simple in its detailing with exposed fasteners and so on. Works well in kind of raw spaces. This is WGS, their new space down in Portland. We also offer this in kind of some other finishes that makes it feel a little bit less contemporary, but it does work in a contemporary space as well. And one of the cool things, we see a lot of our customers use this for things that we wouldn't necessarily have thought. This is a wood cubby hole for this guy's furnace. You slide it aside and you got the wood behind there. It was kind of cool. Then Odin was the product that I wanted to design from the very beginning, but was way too complicated and way too expensive until we kind of took this seriously and could afford to invest more time and energy into getting things right. So designed to be very, very simple, very pure. The hope is that all of these products are timeless, but very, very toned down. And Odin is a Viking god, and he's kind of the old wise guy, so felt that was kind of an appropriate name. And here's some installs of Odin. So it's kind of a cool one. I mean, they're all stainless steel, so they work in wet environments, especially Odin that works outdoor because it has a seal on the bearing. And again, TV covers, we do that more and more for people. And the third one is Balder. And Balder and Odin kind of came about the same time, and it was almost like the names kind of fed off of each other. So Balder is another Viking god. We like them to be pairs because they had a lot of similarities in the way we thought of them early on, both design-wise and construction-wise. And Balder kind of looks like Thor's hammer or something like this, the big thing you hold in your hand with this big bearing. Balder is kind of a young, brash Viking god in Norse mythology. Anyways, but Balder came about by another little accident. I was over in Rob Roy's shop and I had these large bearings and put the bearing on the table and just put my hand in the inside hole and just rolled it back and forth and kind of like, hey, it's it's hubless. There's no need to grab the entire inside. So as basic as it sounds, that is the premise for this whole product. So we then select an appropriate bearing, bearing size, had it custom made, and we get away with this thing. It's very custom, and this is the one here. So the cool thing is you have the outer portion spinning and the inner portion is stationary. And this is Balder shown here in a Portland retail space. This is bypassing application. This is a restaurant in California. This guy had this 24-foot long track with his big painting that I think he wants to stay close to no matter where he's at in his living room. It's pretty cool. It's another, I believe this is local.
Same building as WGS.
Okay, also another commercial space. So that's kind of the three product families, and what we're doing right now is we're doing the same. Let's see if I can turn this beast around here. I think I got it. Yeah. It's heavier than it looks. So what we're just launching right now. Actually, we haven't even gone live on the website yet. Is the same kind of the three product families, but now compatible with glass. So Rob Roy, kind of an obvious solution. Just have the bolt through, and then Odin, that you see here, and Balder still kind of maintain that really kind of clean, seamless front. And one of the cool things. And by the way, we do file utility patents. We take that very seriously. So we do have a utility patent on the way the boulder bearing kind of works, yeah, we've filing one right now for this mechanism, which you can't even see down here. But basically, at the bottom of the kind of invisible, you stick a little Allen wrench in there, and you can actually adjust the panel up to 1 inch in height if you're having two doors that need to touch each other and things aren't perfectly drilled in terms of the holes on the panel and so on. It was something that we kind of took an insight from our customers that had a difficult time if the install wasn't done absolutely correctly, or as I'm sure everybody knows that live in a house made of drywall. Drywall isn't always perfectly vertical, so if you're butting up against the wall, you might want to tilt the panel to just make the drywall look straighter, even though your panel is straight. So yeah, so very, very excited about this. Has taken a lot of work. At the end, I'll do more of a show and tell, and I can actually show you, I'm happy to show you kind of the steps of this process that we go through from kind of sketch all the way through to production for these particular products. So what we try to do is I mean, it's a bold statement, and that's why I say try, but we try to create icons. We don't look at these products as products that need to be updated in a year. We hope that these will, be timeless and live on the market for a long time, and we'll just kind of expand and over time make our product line, bigger, but not replace what we've already spent so much energy on. So we do invest a lot in the kind of the front end, the design, the innovation, but try to take the right decision, even if it takes longer, so that we can kind of get it right in the long term, basically. And I think therefore, we try to keep things extremely simple, and we always ask ourselves, is this detail needed? How can we simplify this in terms of part count and so on and so forth? Making sure that everything is justified. And then I think maybe the most straightforward, but maybe the most important kind of filter we put through everything is this something that we would use, that we would like? Does it, and we put the bar pretty high, and does it surpass that bar? And if the answer is yes, then we kind of go for it. So another kind of, I think, very important aspect of Krown Lab is the fact that we're in Portland, and we're over in the southeast in this building called the Plant, and we do all of our sourcing is in Portland. Not 100% of our components are made in Portland, but we still have some plastic components made in China, but we source those through a local company, and then it's up to them to determine where they manufacture them. We are to this day still, like I said, making a few components overseas, but we're bringing more and more kind of local as we can afford to do so. As a small company, it takes a greater effort to kind of establish the right relationship. If you have a swoosh on your business card, things kind of happen a little bit easier sometimes. But for this is very important, because as a small company, for us to have the face-to-face relationship with the people we work with outside of Krown Lab is very, very important. It educates us. It's easier for us to make clear where our expectations are, as opposed to being on Skype every night with China and so on. When you don't have the budget to just buy a ticket the next day and fly over if something goes wrong, And we'd like to think that obviously we're still young and small, but obviously we support the local economy, which is important for us as well. And one of the things I wanted to kind of share with you is one of the things we have now brought here locally. It was a big deal for us. So we do some of these components. The main steel component here is cast, and we used to do that overseas, and we have now brought that to not in Portland, it's in Boring, Oregon, so just outside. and it's a very cool process to be so close to. So basically it's investment casting, so you build molds, you shoot wax, you cocoon the wax in these things, sludge and a succession of dips to create a buildup of crushed glass and porcelain and all kinds of stuff. And then you heat that up, make it warm, as they say. It looks pretty hot to me. But then you take something really warm and you pour the molten stainless steel in this cavity, which you have before heated up, and the wax has kind of all fallen out. I mean, the Greeks invented this, 2,500 years ago. So it's called, lost wax or commitment casting. So that's now done in boring, which is awesome for us. We see an improvement in quality. We have more flexibility with delivery times and lead times, and we can do more frequent orders in lower quantities. All the things that are great for a small company. And other than that, I mean, we do a lot of basic stuff. I mean, injection molding, CNC machining, tube extrusion. I mean, the list is, there's nothing there that is very unusual. And if you look at our components, you can probably guess, what component is made from what technique. And one thing, as you mentioned, nothing is done in-house. So what we try to do is, we try to look at is, can we do this better than the guy down the streets? And when it comes to investment casting, for sure not. That looks pretty intimidating, right? But we believe that we can do a good job designing, developing. One thing that we do believe that we can do a very, very good job is do the quality control. So all these components are made, overseas, locally down the street. So we have a manufacturer of our tubes or rails on the East Coast. Everything comes into our facility. We literally inspect everything, do all the assembly of all the components and all the products before they go out. So, when a customer receives one of our products, we have not just done an initial kind of quality assessment where you pick up every 10th and look at it. We have also assembled every single one, which means that we can be very sure that we have high quality, and we see that as we virtually have no returns. I mean, we get a return when somebody says that, I didn't have enough headroom over my door, I made a mistake, and we help them and swap the products out or refund their money. And I think that has a lot to do with the fact that we're so close to the tail end of the process, rather than designing and developing and then handing it off to somebody else. In terms of our creative process, I mean, there's nothing unique or special, I would say. You go through the same steps. A few things to point out is everybody on the team, with the exception of our accountants, have a design or engineering background degree, which is awesome, because that allows us to, as a team, kind of come up with what we're going to do next. We can have very healthy debates about pros and cons of going a certain direction. And that is perhaps a little bit unique, because normally within a company you have a creative team that comes up with the design, and what they work on is driven by sales. And we have a much more kind of collaborative effort where sales, development, kind of graphics, brand, product, everybody comes together and we decide together what we're going to do next. And then we go through, and this is what I'm going to show you here in just a second, kind of the steps that we go through. But obviously start sketching, trying to figure out things mechanically, see what works aesthetically. Go to 2D or 3D depending on what it is. We go to a succession of prototypes, quite a few, and then eventually we go into production. So I'll rather than showing this in images, I thought it would be nice to kind of show this firsthand. And that's what this is underneath here. I think I can just pull things up. That might be the best way. So I mean, it's really the same no matter what we do. If you're talking about a very simple component like the spacer that goes between the wall and the trap. Early on, we machine it, you know, just to make sure that it provides enough, you know, stability. Then we go to something called object, which is a 3D printout of the 3D file, where we have, you know, added some of the details that will be necessary for production. And then, you know, tooling is made once we confirm that, and we go through a series of test shots, dial in the color, take care of little flaws like sync and so on, and then eventually, you know, we get these in the thousands, you know. There are maybe a few more steps when it comes to, that's a very simple component, but something as complicated as these components, the main brackets that make up for the big trolley assemblies. Again, I mean, the first step's always the same, lots of sketching, 2D, you know, see what we think works. Then we build it in 3D, and for something like this, we go through, you know, quite a few iterations of this. Again, we build it in this, or print it in this plastic material. It's not structural, but you can check fit between components, you can insert, you know, this more refined version. The bearing inside that we can use to make sure that it fits in the right way. You can look at details. This thing even prints threads, so you can actually thread the screws in, which is nice. And then we're like, okay, I think we're ready. And then we make, you know, big investment. Commit to, you know, purchasing quantity to begin to get, you know, first cast samples back, go through, you know, numerous rounds of feedback, modify grids, it's not right. Then mechanically everything works. We go through, so you start to see finish samples, you know, dive in the finish of it. And then, you know, at the same time, we kind of make sure that we test the crap out of it in-house, because so far it's been, to some extent, really artificial. That's in the use going to work, we've done the engineering calculations, but until we kind of beat this thing up in real life, it's going to help. And then we do that. Load test it to more than twice the maximum capacity load rating for the system and those commercial and so on and so forth. So it's not, you know, boiler and all work the same way. And then for the version that you see here, which is, this portion is the same, but the bottom portion is different, which I have to say is one of the more complicated things that we've gone after. It's a lot of fun. So we really wanted to have some kind of adjustments. Through a brainstorm session, we came up with the idea of, let's use a little Allen wrench in the bottom here, so it doesn't look on the outside is completely, you know, not visible. All our competitors have these visible adjustment mechanisms. So we came up with this idea of this kind of sled. So we do, you know, a very crude prototype, which is almost no investment at all, money-wise, it's laser cut parts, you know, put together. That proved out, works really good, you know, where the travel is the initial adjustment depending on the door panel. Then we look at 3D for an early version of it, and then CNC this because we wanted to test it on the load because there was a lot of tight spacing here. We CNC this and just weld it onto, you know, test piece. We could now we're actively kind of test the system. Design is being refined all the time. You know, you get really close to the final. So you can see that it's evolved a little bit. It's a Krown. You can make that to be square. You can shorten this up a little bit. This again is one of those 3D printouts. So you're not structural. You can test the typical components. Do a final kind of cosmetic check as well. And then we decided to look to the product kind of shorten it a little bit, which didn't affect anything else. And then this is not what we do with the local. We went to tooling, mold making and boring. And then after the molds were made, we could look at these waxes. This is what comes out of the mold that then get put on these trees and then dip in this slurry to make it glue, right? And here we could actually look at, you know, even finer details because we handle production calculator, but the mold maker makes changes and so on. inconvenience the gates and less technical details. They're totally too much. But anyways, then you do that, and then this is first article, off of from the foundry, and with a little bit of luck, maybe, like with a lot of, I think, a good process, no surprises. Everything goes like grades, quality is higher, better finished, lower reject. And I'd like to think that I've got through all these steps, and it's a lot of work, but fun. I think this is where the magic happens. I think it's coming out with design is one thing, and taking you through the gauntlet, like I said earlier on, that's a lot of times where a great idea kind of gets watered down, or this is one made of later mixed with product, it's fragile, or too expensive, or not profitable enough for the company, all bad things. So yeah, that's pretty much the last thing I want to share is, as you can see by comparison, this is the very, very first one. So it still has the same DNA perhaps, but quite different. This little wood dollar in here, there's like a hard off the shelf. The equipment isn't the nicest one in the room or clean up, but it worked. And this is where we are today. Then I have a few more things to share if you didn't know what you guys are interested in. So if you feel free to ask me questions, and I might have some backup slides to point to.
I'm curious about your decisions to do investment casting versus CNC. What are the factors that makes casting the route to go?
It's cheaper, significantly cheaper. And obviously you have to have capital investment up front, where you got to pay for molds, and you're putting a big stake in the ground, because beyond the mold, you have some flexibility to go in the US and locally, but you have to commit to a certain volume, right? And if you make a mistake on those, you're stuck with that 500 times over, right?
So it's very, very careful prototype. You absolutely.
Yeah. Well, with CNC, it's like every one is a prototype.
Right.
Just an aspect. So yeah, that little bar and stump that CNC and stainless steel right there on this guy, that's $300 just that little piece to get CNC all the way. If you run this maybe in a place that's it in high volume, might be a little cheaper, but it's a lot of money. Because it's stainless steel. Aluminum is pretty cheap in CNC, it's a lot quicker. Stainless steel is a very powerful machine, and a lot of big changes.
Stefan, can you give a ballpark figure for the investment casting cost? Just the tooling that is required?
Yeah. China or overseas or here? It's actually quite reasonable. Part of the reason is China tends to use steel molds, and here it tends to be aluminum. And per mold, so per part, it's about $5,000, because it's a simple, straight-up shot. It's a very shallow mold. It's just the depth of the part, and then, we never get it quite right the first time, so we've done a couple of modifications to it, which you can do with your steel save. It's supposed to remove the material pretty inexpensively if you have to weld up the mold and make CNC again. Any other questions?
Same thing of that. The ballpark number of here's prototype cost of a part, here's a DC cost, here's a maybe the warranty cost of each of these kind of things. Just to go flavor of well, this is $100 I can say for
good. I don't want to share, detailed pricing on every single component, but as an example, if you go locally to a place that does nothing but turn parts all day, that's quantities of hundreds to tens of thousands. Depending on the volume, let's say we're 1,000 of these, you might get these for $2 a pop. So that's a lot of material, it's dead, it's pretty expensive. So yeah, so that's $2. This is 25 cents. But you have the $3,500, $4,000 mold investment. And then there are these hidden costs, which I can add air shipping parts because of late. Communication for sure. I would say there's pros and cons, and then when you think you have everything locked in, you go for it, that's when you realize that, oh, we didn't think about that, and we should go make that, and then you sit there, sometimes sit there with one of your away from. So, I mean, we started, I think the first couple of hundred kits that we sold, had this, so we could delay the investment of the tooling of that, into a long volume. 3 years is a long time in some ways, but it was quite quickly. I mean, it feels like almost yesterday when, they want us to order 1,000, can we ever sell it? And now we have a little bit more confidence that, talking through every argument, we have a history, so we know how quickly we burn through parts and so on. And it makes it easy to make a decision. And really, it's a great question because it's something we ask ourselves every day. We're working on a ladder, for example, that's compatible with our products for like libraries or cutting holes on high or something like that. And we have lots of discussions, and we believe that this will be a successful but fairly low quantity item. So we have deliberately made design decisions that allows us to CNC parts early on, and turn parts, and delay injection molding of some of the details until we feel like a proven track record and make sure it's the sweet spot for the confidence. And if you don't think of that front, you could have to do a complete redo. But if you consider that up front, it's quite possible to kind of keep it in check. Do one thing first, and then invisibly to the customer, change it to the injection molding. The performance of the parts the same, it looks the same, so basically the same.
Bringing that out, your examples of the different technologies and why you pick one, and that there's all learning field there. Professor of the Art Institute, the ID program, and the student at the ID program should see, here's the real samples, and this is why you go one or the other. You've got a whole story there that could be paramount for the two design programs in our organization.
Yeah, it's like I said, this is where magic happens, right? I mean, I'm not saying it's easy to come up with a great idea, but I think it's equally challenging, if not even tougher, to take a great idea and get it through, through development, through production, through, especially maybe even harder in a big company where there's more people involved in decision making and so on. And I admire, and everybody was able to do that, especially in a big organization. Where I went early on, and we kind of refer to it as babysitting. We kind of have, we can't just do design and hope that the rendering, includes all the details that everybody needs, and a year later, there's a box on your desk with the product, right? And you have to kind of follow it through. And I believe it makes you a better designer, knowing some of that stuff. Yeah,
so is this your first experience with having other food designing an absolute product? Or had you done design work and took it further before?
Yeah, I had, I would say that I have gotten one step closer to manufacturing, doing this, like, and specifically like visiting the foundry, you know. But all other aspects I have experience doing prior. I spent a lot of time in China and Hong Kong working with engineering, manufacturing divisions and companies, seeing, been through the facilities where things are assembled, the logistics and so on. Very much what I wanted to, because I wanted to learn. I understood that sort of things we could screw up, where decisions could be made that, as the designer of the product, you might not agree with. You can be very kind of understand the decision making and work with all the other functions and help make decisions together. What comes out of that, but yeah, to have experience doing that, and it's been nice to. That's sort of why we want to bring it over, so you can go to a foundry, you can go to a company that turns steel parts and so on and so forth, and troubleshoot it's not live.
So you were working with a pattern maker to do the 3D printing, is that?
There's a couple different brands, but we use a machine called object machine. So basically, whatever you do in 3D, you export it as STL, and the software of this object machine kind of takes that file and slices it into thousands of slices, and then it's printed plastic.
Is that done in-house?
Yeah, we have one of those in Blue. Yeah. And there are many companies that can do this still. It's not cheap, but it tells you a tremendous amount.
Yeah, I was gonna ask about the interface between that process and the investment casting. Is there a clean line at which that breaks, or is there some back and forth between the two?
We try to make it as seamless from one step, or as smooth from one step to the other, so that you don't kind of thinking more of the thing and go to the next step, and you didn't, so you end up with something that doesn't work out. And what we're able to do now, which is the one piece I don't have here, because it was literally melted. It was after we did the baby blue printed out by it. We then got really good. We then spent a little bit of money getting the same part made in wax. You can print it. It's a machine that prints wax. And then we can take that to the foundry. They could cocoon that, burn that out. It doesn't create a super nice surface because the wax isn't optimized for moving the shell and this and perfectly smooth. But that gave us, a fully cosmetically correct, 99.9 mechanically, structurally correct part. So as long as that worked, there was very, very little risk going to tooling or mold making, because as long as the right data is sent up and the right data is cut, But yes, we try to do that as many steps as we can without slowing things down. So
And then do you have any idea of the timeline from the initial concept of the part to when it's final?
You mean like concept to production, or what are these steps in particular?
Concept to production.
Well, we go phase mount, so the product kind of mount through. From the time we decided to pursue that till now is over a year, longer than I like to say. But it has been, everybody's wearing lots of hats. I mean, if we were full-time, a person on that project full-time, we could have done it in a matter of months. But we don't mind doing it a little bit slower. Give us some time to reflect and marinate and so on. So by the year, I think depending on the complexity, it's anywhere from, for us, if we decide we want to pursue something new, it's something very simple, like an accessory, like a door handle, for example. That's 6 to 9 months from initial concept until you have production, volume on the shelf, website live, photography and specs and drawings and install instructions and everything. 9 months maybe. But then it can go up all the way to well past a year. The level of complexity is high. And some of that is also investment. If it's a product that we need to spend, build 5 molds to get off the ground, commit to large quantities, we're obviously a little bit more gun shy and we take it.
And dealing with your local companies, is lead time an issue often? Because I'm guessing it's sometimes.
Yeah, I mean things slip, inevitably unless you're, parked outside a vendor in a caravan, and plug in every day. Yeah, generally you add a certain percentage to whatever they tell you, and you learn, over time which vendors are more accurate in terms of what they project and others who are not. But in this particular case, it's been a little bit of tight here towards the end to get everything ready. The word got out, and we started we did the interior for Skylab's new office, Jeff Krown, and there's something we weren't going to pass up. And they're using this product, Boulder, for glass, and it's working out great, but it's a little tight on time for a little while. As in, if we had been further delayed, they would have actually had to wait for products. I always want something to happen faster.
On the concept phase of things, you talked about doing a doodle and you hand it off and you're sticking it, and you expect that to be God, and it's going to come back. Versus your stuff has a very, you're letting the materials and the parts breathe.
Oh, yeah.
Can you kind of articulate, did you get inspired by doing a process? Was it just your virgin idea at the beginning? Or when did you get aha moments?
Well, I mean, everything, and I think I can almost speak for everybody at Krown level, is to try to just keep things really, really simple. And that usually means that you let the material, the raw material, kind of show through as opposed to kind of covering it up and making things more ornate. When it comes to the overall kind of trolley system, the design is synonymous with the process. There is no other process other than machining that allow you to get the geometry that it did. So heavy, bonded, laser cuts, components and weld them together, then the design will look very, very different. And that was an aha moment when we kind of picked the process very early on. And for me, it was a very new process for me. The thing I've done was forging. It's supposed to be forged as well, cold forging, but pretty expensive. But that was a big aha moment. And reading up on that, kind of understanding it better, made me understand what we could do, and we were able to combine those 3 parts into one, and so on and so forth. Over the particular process. And it's also what allowed us to keep things really clean on the front, not having invisible fasteners. It's all because of that process. I mean, again, we could have achieved it with machining, but not much.
We were getting emails after you had this wonderful house, and so you had confidence that you wanted this, and then kind of did you feel like you needed to have
Yeah. I mean, it was very simple. That house was, in a handful of magazines, a handful of books in the U.S. and abroad, and every single person that contacted me, they referenced or a bit of the photographic master for an hour, which we knew was well there for, right? And so it was very, and I've been doing well for years, and so it was a very simple choice. Yeah, you can just got advertising well. Maybe with some luck, the same readers are still there. Now we can find it back and tell them we have it, and that's pretty much what happened. So I remember our ad went live, and we were like, "What if the phone something? What if nobody sends us an email?" But it happened, and so yeah, slowly but surely you can afford to become more confident. But we are self-funded, right? There are no investors, no angel or nothing like that. It's hard-earned money, and if you therefore run the company with a deficit for any period of time, other than the very, very beginning of the abroad, the doors shut very, very quick. So perhaps as a funded startup, it's a little bit you have in a group of investors where perhaps you have the capital and the need to do the shotgun approach to see what sticks and you go after those things, and you have the money to kind of spend on all those bullets. I think as a self-funded startup, you have to be much more like a sniper. Try to find the right target and go for that, and then hope that you hit it, and then then aim for the next thing. Yeah, well has worked out great for us.
The house was in essence, your market budget. Building the house. Were there other things in the house that you would have thought, or are there other details besides this that you wondered, why those other things? Or
a couple, and especially there were a few that never made it off the drawing board. We have, it's often things we like, but we do talk about what we're going to do next. But for us, we feel that we still have so many interesting ideas that we want to pursue just on slidable hardware before we feel that we kind of have that wrapped up. And always continue to improve and sell and so on, but then focus more energy on the new pack. But the house wasn't really tied, other than this kind of happy accident that people saw it. But it wasn't intended to launch a company from that. It was just a happy accident. Then leaving Nike and consulting for companies like Nike, Microsoft, was able to put aside some money that was used as the seeding money for.
How much experience did you have working with metal prior to doing this company? Just like
not a whole lot. I think designed, not detailed knowledge. Like most guys, I used to build Harleys, as a kid, there's some metal work there, I suppose, and being interested in architecture, and having done a couple of architectural projects, where steel components or metal components. Really, I think my first detailed experience in metal is I designed a lot of watches. And watches uses a lot of metal, both stainless steel and aluminum, and lots of different processes, forging, casting, CNC. I think that helps. But this is a completely different scale, it's quite different, and tolerance is very different too. But yeah, just learn, and still learn every day, which is part of fun. And again, a big part of why we're doing everything we can to stay local, have as many local relationships and manufacture locally is we learn from that. And if it's over in China, we send a CAD file and we give feedback on the sample and eventually production shows up. There's a tremendous information lost. There's an amount of information lost in that process that we would like to gain.
What percentage of your sales are in the first? What are your sales? Like, what are your distribution numbers?
Yeah, it's a good question. I mean, in terms of how we sell, we advertise, trail, interior design, we sell direct via customers using those ads. And also now, I think, searching for slightly more hardware and finding us. We also have 46? 45, something like that. Points of distribution in North America. So we have basically dealers. Some have more of a brick and mortar focus. Some of them have more internet web focus. So we sell through them as well. In terms of how many, since we advertise in national magazines and we haven't done anything like important monthly or anything like that, I don't think that we have. Do you know that what our local sales are?
Yeah, it's a lot of word now.
And then maybe, yeah, so that I think is going to help us, locally. I mean, I know Jeff from before. We approached him and said, hey, it's he was about to move, so he said, let's do this together. Let's provide you with hardware. So it is, it's word of mouth. I think aesthetically, maybe we do fit well in with kind of important sense of style, and therefore we do see more than a few local installs. We're obviously still predominantly, we do sell in the United States, we know for sure, more and more to Canada. And
Norway recently.
Norway, we're selling in the UK,
Australia,
New Zealand, so a little bit all over. France, and Nigeria today. Which first we thought it was maybe like something.
Chevron, I'm like, who in Nigeria can
yeah.
But yeah, so
his brothers, the relative of the prince.
Bank transfers.
If you only do this, we'll give you $10 million.
Yeah.
No, but we have our first, African continent sales today. Pretty cool. So, yeah, which is exciting. So this is actually how our map looks like in North America. You can see the cluster of dealers, points of distribution.
Nothing in El Paso.
No, that's right.
The codes, I'm focusing on the codes. I know some people.
Yeah, fix that, right?
We get random, just right. Texas, for example, for a while, we were getting a lot of increase in Texas, and we didn't know what was happening there.
Yeah, because you walk around with all these assumptions, like, oh yeah, we're gonna, it's New York, LA, maybe Chicago, contemporary, or contemporary buildings on anywhere else. But I'm surprised. There's a lot of Texas, a lot of Florida, you know.
No.
Well, I mean, these are points of distributions. We still sell to Vegas. It's just that there's no brick and mortar store in Vegas. Is that?
I was.
So yeah. The last thing really, if this aren't any other questions, I put this in there, I don't know if it's going to come up or not, but I think these are two extremely important things. When you try to do something like what we're doing. And it's fantastic to be naive, because then you just don't know all the things you're going to stumble into, or the problems that you will have kind of. And maybe if you did foresee all those things, you would be able to be naive. But you also have to be, and I think that's equally, maybe even more important to be stubborn, to just not give up and push through when things are difficult. It's different to work for a startup, for a very small company, from what young companies will do with fun. It's not your average kind of 9 to 5 gig. But there are some upsides for sure, and you write your own tickets to a great extent, or you put a little box and here's what you do. And you do this for 5 years, and you put the company policy, you're allowed to get promoted, and so on. And this is, we have much more flexibility and freedom. So pros and cons, but yeah, being naive and being stubborn is great. And those are two things that I definitely possess. Ask anybody around me. All right. Thanks.
Thanks so much, Stefan. The next meeting commences on Tuesday, June 28th with Chris Higgins. Chris Higgins is a writer based in Portland, Oregon. He mostly writes for Mental Floss magazine and their website, though he recently had a story on This American Life and had a cover story last year in the Portland Mercury. He's also an iPhone developer working with 90 Day Studios. He helped create Peekaboo Barn, Peekaboo Wild, Big Fat Lies, Life in Short, Cocktail Compass, Nick Jr.'s A to Z with Moose and Z, Quibble, Savage Love, and a bunch of other acts. It's going to be good. So thanks again, Stefan.
We have a product quality if you'd like, and touch anything. There's here. Very, very good. Everything's a whole different. Oh, hey! Good. I haven't ever mentioned before.
Does this have the security mounts? Does this have the security mounts on there? It does. Okay. I just figured it out. Oh, sorry. What I've got is, what's not, I'm curious, you've got most of your stuff is through a wall. And I've got it, I'm putting a small room on. And I put it in shelves and I foot down. So my foot started to fall up. So I've got a foot or so out where I can hang a wall and use that as sliding doors as a couch. So, but there's not this thing. You have a rig suspended?
We do with
just kind of a thing or that kind of thing?
we do with some limitations. Yeah, I mean, feel free. I don't know what it's. I think what I can do is I just do record that every time sales
But she's like, I guess, yeah.
It's awkward.
Can't pick them up again? Was that? Can't pick up their address.
Yeah, I wrote this blog.
Did you pay him to have it up or in
University of Illinois. Did you play tennis too?
No, I good group of people.
On my back talk, I quit 15 years ago. I think I bought a racket.
But I got you to say this.
Yeah, let's do it.
Yes, it's low on the road, but rock text on the inside, you know?
I just see that.
There is a sand casting guy. There's a bunch of areas. I did one project. So they,
And also like.
and it was actually face or in his face. Because the next one to make it but what the next one that was in the next section is how it won't be working in shape. And I had a pattern guy figured out. But as you get test the leg, that was just push it up on the cat. And then the balls that you had, you went back on the bottom and did all the spill in your seams and made it so easy to cat. So when you first said you're a bunch of techniques and you're all in one